calculating and using the molar mass of heterodiatomic compounds, which basically means compounds where there are two different elements in them. So the key to answering these kind of questions is being able to convert between mass in grams and amount in moles using molar mass. So remember that molar mass is essentially going to be your equivalency between amount in moles and mass in grams. So for example, let's look at this question, rubidium chloride. First things first, we have to look up the molar masses for rubidium and chlorine so we can calculate the molar mass of rubidium chloride. So rubidium here is in group 1. Oh my gosh, that's very low resolution. I think it's 85.448 grams per mole, so use your periodic table. And there's 1 rubidium to every 1 chlorine in this compound. So chlorine is 35.453 grams per mole. So add those together. I'll get my trusty 10th grade calculator. 35.453, and that is 120.901. Obviously, if you were doing this in the ALEKS program, you should be using the ALEKS data, okay, because otherwise you may get different numbers of sig figs, but I've just got this periodic table here. So going to make a plan. We've been given mass in grams, so you want to convert between mass in grams, and you want to end up with the amount, which is going to be in moles. So I would rewrite your molar mass in terms of a equivalency. So this 120.901 grams per mole means that 1 mole of rubidium chloride weighs exactly 120.901 grams, okay? You can do that with the molar mass for anything. Equate the molar mass in grams is equal to the mass of 1 mole of whatever that substance is, and then you can just write it as a unit conversion factor regardless of which direction you're needing to convert, whether you need to convert from mass in grams to moles or vice versa. So in this question, we are given 55 grams of rubidium chloride. So it is the grams that I'm going to want to cancel out. So where I've written my arrow, my plan is where I'm going to put my unit conversion factor, which will be 120.901, stays with the grams, and then the 1 mole of rubidium chloride stays together. So my mass in grams is going to cancel out. So essentially what I'm doing is 55 divided by 120.901. You may have learned this before in terms of trying to memorize something like, hey, if you want to convert mass in grams to moles, you divide by the molar mass, or if you want to convert moles to mass in grams, you times by the molar mass. But trying to memorize something like that, it's 50-50 if you're going to remember it right. So it's much safer to use the concept of dimensional analysis. Much better to just make sure that you use that equivalency and then write a unit conversion factor such that the units that you don't want cancel out and the units that you do want remain. So we get an answer of 0.454917 659 blah 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 blah, and those units are going to be moles because the grams are going to cancel out. Now we're asked to give the answer to 3 significance digits. That's because we are multiplying or dividing. The weakest link would be number of sig figures. So that is going to be rounded to 0.455, if I could type properly, okay? Because that will round up. So I'm just going to draw a little line in there so you can see my unit conversion there, 1 over 120, and you can see that my mass in grams cancels out, leaving me with units of moles of, if I'm going to be specific, rubidium chloride. So that is how we do that kind of conversion. So let's see if we get asked to convert mass in grams to moles or whether we get to do it the other way around. Let me just see if we can do one the other way. Grams, grams, grams. Are you going to give me a moles to grams, or do these all go one way? We'll give a couple more guesses. Moles. Wonderful. Okay, so now we have strontium sulfide. And again, before we do this, we are going to want to work out the molar mass of strontium sulfide because that is going to be our conversion factor between mass in grams and amount in moles. So strontium sulfide, then strontium should be here in group 2. So 87.62 is the molar mass of strontium. So 87.62 grams per mole for strontium. And then the sulfide will be over here, 32.066, I think that says. grams per mole. So add them together to get our total. So 87.62 plus 32.066 gives me 119.686 grams per mole. So I think it's always smart to rewrite that as an equivalency. Okay, 1 mole of strontium sulfide weighs exactly 119.686 grams. Okay. Ooh, not what I meant to press. Okay, so our plan then is we're going to want to convert between amount in moles to the mass in grams. So our conversion factor is going to be this equivalency here, that 1 mole of strontium sulfide weighs exactly 119.686 grams. So my amount in moles was 0.080. Moles. Okay, so I'm going to want moles on the bottom this time, so it cancels out with my given units of moles. So the 1 mole stays with the strontium sulfide, and then that weighs 119.686 grams. Okay, so that is going to cancel out the number of moles. Okay, where did that X come from? I don't even know. So what you're essentially doing is 0.080 times 119.686. But you can see that those units are cancelling out, so I can be confident I have done that correctly, and apparently I can't use my calculator. Got a sticky button today. Okay, so that comes out as 9.6706288, and we can see the units will be grams because the moles are going to cancel out. Now this 0.080 moles is to 2 significant digits, right? Because the leading zeros don't count. So I'm going to round to 2 significant digits, so that's going to round up to 9.7. Whoopsie, I hit that a bit hard. 9.7 grams. So let me just draw that little line on there for my unit conversion factor and show you that moles will cancel out, leaving me with my final units as mass in grams. All right, I'm going to do one more just to make sure we can deal with anything that is thrown at us. These are very simple compounds. As you can see, they're all 1-to-1 ratios, 1 mole of this to 1 mole of that, right? In the empirical formula, I don't see any where we have like a composition like, I don't know, lithium 2 oxygen Li2O or anything like that. Okay, so they're all like 1-to-1 mole ratios, keeping it simple. So let's see, let's do a different one. Just trying to pick something with the molar mass we haven't done before. Okay, potassium iodide. Okay, so again, you'll get the molar mass of potassium iodide. I'm going to leave that up so we can compare. So the molar mass of potassium iodide is going to be, well, we have to look potassium, and that's hiding. Potassium is 39.058, I think, if I can read that. 39.058 grams per mole. And the iodine over on the right side here is 126.904, I think. If I could read, this is very low resolution. I do apologize for that. So we can add those together, 39.058 plus 126.904 gives me a total molar mass of 165.962 grams per mole. Okay, and of course the rules for sig figs, etc., when you're adding or subtracting is you will maintain the smallest number of decimal places, which is 3, so that's okay to give that to 3 decimal places. Okay, so every 1 mole of potassium iodide weighs exactly 165.962 grams. Okay, so I am trying to get from the mass in grams to the amount in moles. Ooh, that's a long arrow. Amount in moles. Okay. That'll do. All right, so the mass in grams was 57.8. We want the grams to cancel out, so that 165, if I could type it, 0.962 grams will go on the bottom, and 1 mole of potassium iodide goes on the top. So I know I'm going to get my units in terms of moles. So 57.8 divided by 165.962 gives me 0.348272496, and that is moles of potassium iodide. So we've got 3 sig figs here. and we're dividing, so we're going to go to the weakest link, which is going to be 3, like so. All right, that will do.